Okay, this is question 3, part 2. The total resistive force acting on the system is 40 newtons, and its speed is 8 meters per second. Calculate the useful power output of the cyclist. Okay, I highlighted my G's, my givens, 40 newtons and 8 meters per second. And my unknown is the useful power output. Well, if you look at the formula packet, P, power, is equal to F times V, force times velocity, or speed, force times speed. All right, and one thing I want you to see here is also power is equal to work divided by time, right? But in this case, my power equals 40 newtons, 40 newtons times 8 meters per second. All right. And work is a Newton meter, right? Force times distance. Work is force times distance. All right. If I take 40 newtons and multiply by 8 meters per second, I end up with 320 Newton meters per second. Okay. Power is equal to work divided by time. Work is Newton meter, time seconds. Okay. So also you could write this as 320 watts. But I just wanted to show you that, how it's related to work divided by time. Okay. C, the cyclist stops pedaling and the system comes to rest. The total mass of the system is 70 kilograms. All right. So in this case, it's a F equals ma equation. I have the force. The force is 40 newtons. All right. The mass is 70 kilograms. I just need to solve for A. From the equation F equals ma, F divided by m equals A. All right. Plug in the numbers. 40 newtons divided by 70 kilograms. And remember, a newton is a kilogram meter per second squared, right? So if I take 40 newtons and I divide it by 70 kilograms, I end up with 0.57 meters per second squared because I've canceled out kilograms, right? Easy enough. That's my acceleration. Now, estimate the distance taken by the system to come to rest from the time the cyclist stops pedaling. Okay, so I'm gonna take some things that were given to me above. The system has to come to rest, so the final velocity is 0. My initial velocity is 8 meters per second. I highlighted it up there. Okay, that's right here. My acceleration is 0.57 meters per second. So what I'm going to do now is I'm going to use this SUVOT checklist to figure out what I need and what I have to figure out which equation I need. S, that's what I need. Okay, so that's in the equation. I need to find a SUVOT equation that contains S. I have mu, right, 8 meters per second. I have my final velocity, it comes to rest. I have my A, 0.57 meters per second. I don't have T. So the equation that I can use for this is V squared equals mu squared plus 2AS. If you don't believe me, look in your formula packet. All right, and use this method to figure out which equation you need. Okay, I manipulated this equation ahead of time to save time on the video. Okay, V squared minus mu squared divided by 2A equals S. All right, and the velocity and the acceleration are opposites. So if the velocity is positive, the acceleration is negative. All right. So my v squared is actually 0, so I can actually cancel that out. Mu squared is 8. Okay, so I'm going to solve it over here. Negative 8 meters per second squared. Okay, and I got to square that. Divided by 2 times 0.57 meters per second squared. Okay. And I'm gonna just do this in one calculation. This is equal, so equals distance. Okay, this is the solve. This means solve step. This means distance traveled. From this I get negative 64 meters per second squared. Sorry, negative 64 meters squared per second squared. And on the bottom, I end up with I have meters per second squared. So if I take meters squared per second squared and divide it by meters squared, or sorry, if I have meters squared per second squared and I divide it by meters per second squared, I can cancel out the seconds here. Okay, and I'm left with just meters. All right, this meter actually cancels out too. And I end up with 56, S equals 56 meters. Okay, there's one more question on here. It says, give me one reason why your answer in C is only an estimate. Well, as you hit the brakes on your bike and you start to come to rest, the air resistance starts to drop off as well. So this force of 40 newtons isn't constant as you're braking. Okay, that's it. See you in the next video.